Hello and welcome guys to Unacademy Studios Bridge. This is the team of Unacademy Studios Bridge and I'm Marut Tiwari. I did my masters from IIT Kharagpur and I've cracked GATE multiple times, and I'm also an author of the book GATE in 75 Days, which is one of the best sellers in GATE segment. Follow me at marutlife-4661 to keep getting updated with all my courses and all my free special classes on Unacademy Learning app. Today we are going to continue GATE questions based on slope and deflection, and particularly for simply supported beams. As you know, in previous sessions we have been solving the questions based on cantilever. Okay. But before we go ahead and start discussing about the topic itself, you should know that there are number of advantages in preparing through Unacademy Learning app. For example, you can experience so many courses for free, and you can follow the flexible schedule. You can follow the courses in the language of your choice. You can watch them as many times as you want, and the biggest power of Unacademy platform is that when you attend live classes, then you can chat with the educator. You can literally ask and solve your query right there while you are attending a live class, and you can get your response in real time, and you can participate in interactive polls, and you can learn anytime and anywhere. There are flexible packages available. You can go for a 12 months package, which is available at 25,000. You can go for a 24 months package, which is available for 40,000. And before going for the subscription, don't forget to use my code MTLive. Don't forget to use my code MTLive to get 10% additional discount. Okay. So go ahead, install the Unacademy Learning app and choose GATE or choose ESE as your goal. Then choose any one package as per your convenience. And my dear friends, use my code MTLive to get 10% additional discount. So I told you so many reasons. I told you so many motivations that if you are preparing for GATE 2021 and if you are preparing for ESE 2021 or even 2020, then why should you choose Unacademy? But apart from all these advantages and all these reasons, let me tell you three big things. On Unacademy, you get convenience. Attend classes anytime, anywhere. Follow your schedule. This subject I'm going to attend first, then I'm going to attend this subject, and blah blah blah. So it's your wish. The second thing, first thing, convenience. Second thing, top-notch educators. Top-notch educators. You saw my credentials. Similar credentials educators are available on both GATE and ESE platform on Unacademy Learning app. So convenience is there, and quality is there, and cost effectiveness is there. That you don't have to bear any traveling expenses. You don't have to incur any daily coming going and hostel and so many things. You can just keep attending the classes from your phone. As simple as that. Alright. So guys, go ahead, install the Unacademy Learning app and choose your goal and keep your preparation lively. Now let us discuss about these simply supported beams. In simply supported beams, we have two major type of problems. First type of problems can always be done by breaking the beam into some standard beam or something like that. And these standard beams you must remember, okay? These standard beams you must remember. That is the best way to solve the problems quickly. That is the best way to solve the problems quickly. So, in simply supported and overhanging beams, my dear friends, the type 1 problems are which can be broken into standard beams always. And for that you must remember these three standard beams at least. You must remember these three standard beams, at least these three simply supported beams. Number one, a simply supported beam with a central point load. Number two, a simply supported beam with a UDL. And number three, a simply supported beam with a couple acting at one end. Couple acting at one end. Okay, so these things you must remember. So what you must remember? I'll tell you. Focus yourself here and try understanding how this beam is going to deflect. You think about it. How this beam is going to deflect. How this beam is going to deflect? This is simply going to sag like this. This is simply going to sag like this. And if it is going to sag like this, then it will have maximum slope available here, and it will have maximum deflection available at the midpoint. Maximum slope, please remember WL square divided by 16 EI, and maximum deflection, please remember WL cube divided by 48 EI. Now, what about simply supported beam subjected to UDL throughout? This is also going to sag. This is also going to sag downward like this. And once again you have maximum slope available here, and you have maximum deflection available here at the midpoint. Now maximum slope is gonna be omega L cube divided by 24 EI, and maximum deflection for this beam is going to be, maximum deflection for this beam would be 5 omega L raised to 4 divided by 384 EI. Now you think about this one. Now you think about this one. This one is again going to sag downward. This one is again going to sag downward, and its maximum deflection will take place at L by root 3. And what will be that maximum deflection? That maximum deflection will be m naught L square divided by 9 root 3 EI. And what about the slope? Here the slope will not be equal. Here the slope will be different at both the ends because symmetry is not there. And the slope at the left end will be m naught L divided by 6 EI. And the slope at the right end, will be m naught L divided by 3 EI. Please mark them up. Pause the video immediately and mark them up. If you're watching the premiere, then make sure that you take a screenshot and please mark them up. Please memorize these formulas, all these standard cases, to solve at least type 1 problems. Please, my dear friends, memorize them, and after you memorize them, then we can go ahead and start solving the problems. Simply supported beam subjected to symmetric concentrated load at the mid, then simply supported beam subjected to UDL, then simply supported beam subjected to couple. Okay, please memorize them, and then we go ahead and try solving some problems. For example, this problem they asked in 2003. This problem they asked in 2003, simply supported beam found to deflect more than a specified value. You want to reduce the deflection. Now, if you look at all the deflection formulas, any deflection formula, then you always have a pattern. You look at any deflection formula and you have a pattern. What is the pattern? Load, length, elasticity, moment of inertia. Load, length, elasticity, moment of inertia. Load, length, elasticity, moment of inertia. So every single time you have a pattern. Load, length, elasticity, moment of inertia. Load, length, elasticity, moment of inertia. Here again, load, length, elasticity, and moment of inertia. So you have a pattern here that every single time the deflection can be written as load into length. Maybe sometimes length is square, maybe sometimes length cube, or maybe length power 4, but load into length and then elasticity into moment of inertia. If you want to reduce the deflection, first option they are giving, that increase the moment of inertia. Increase the moment of inertia naturally. If you increase the moment of inertia, naturally the deflection will reduce. So first option itself is the matching one. Bingo. This is the second standard beam. This is the second standard beam, simply supported beam, and this is a 2 marks problem. Incidentally, they have asked cantilever based problems much more than simply supported based problems, but nonetheless this one is very simple. They are asking Y max. You know already for this beam Y max is 5 omega L raised to 4 divided by 384 EI. My dear friends, we have omega value given to us 120 kilonewton per meter. So this will become Newton per mm. Length of the beam is 15,000 mm. Elasticity is given as 200 into 10 raised to 3 megapascal, and moment of inertia, width and depth both are given to you. So you can calculate moment of inertia as 120 into 750 cube divided by 12. This was a 2 marks problem, but should not take more than 10 seconds for you to solve, because this was directly formula based problem. Now here you have a problem that they asked in 2009. I want you to look at this problem very carefully. Please look at this problem. Please read the problem very carefully. Then I'll describe the solution. They are asking vertical deflection at the point of application of the load. So please go through this particular problem, and then I'll go ahead and try solving this. Okay, I hope so far you have understood the problem. Now listen, if you have watched my previous session, then in the previous session, we have solved a problem like this, which we broke into 2 cantilevers. We said that take this part as a horizontal cantilever and take this part as a vertical cantilever. So my dear friends, if you remember, in the previous session we have solved an L-shaped frame problem where we have broken the frame into a vertical arm and a horizontal arm. Similarly, we will do it here. People are going to prefer a strain energy method, and that's not a wrong thing to do. You can prefer a strain energy method and you can prefer Castigliano's theorem also. No problem. But as long as you have a frame of 2 arms, then they can be done using a simple trick. And that simple trick is that this particular frame I'm going to break into a cantilever. You hide this much, then look, remaining thing is looking like a cantilever. And then this vertical part is simply supported. This part is just like a cantilever. This part is just like a cantilever. This purple part is just like a cantilever, and that vertical part is just like this. That vertical part is just like a simply supported beam. Look, you have one hinge and one hinge. So let me break this. let me break this into, this is given to you, this hinge is there, this hinge is there, and then it's not like two different parts, it is like one continuous thing. It is like one continuous thing, and then you are applying P here. So I'm going to break it into two beams. One, this horizontal part which is behaving like a cantilever, which you can take as cantilever because this is going to deflect itself. This is going to deflect itself, and its deflection will be, if you have watched my previous session, then you know for a standard cantilever the deflection is PL cube by 3EI. Deflection is PL cube by 3EI. Now transfer this P. Transfer this P here. Transfer this P here. And if you transfer this P here, you'll get P and you'll get P into L. And remove that much. Remove that much beam. And just think about this much simply supported part. Just think about this simply supported part. P is anyway an axial load, and that will not be responsible for any lateral deflection. P into L is a couple. P into L is a couple acting here in clockwise sense. Please be very attentive, okay? Now what this P into L will do here, this P into L, my dear friends, is going to create some, this P into L is going to deflect the beam forward. Deflect the beam forward like this. This P into L is going to deflect the beam. This couple is going to deflect the beam. This P into L is going to deflect the beam forward. Then it will have some theta here. Then it will have some theta here. And if this part is going to rotate, then along with this, even that horizontal part is going to rotate. Even that horizontal part is going to rotate. If this is theta, then even your horizontal part is going to rotate by the same theta, just like a bell crank lever. Just like a bell crank lever, it is going to rotate by the same theta. So what will be the displacement here? Displacement here will be theta into L. Displacement here will be theta into L. Now that means this horizontal part is deflecting itself, plus this horizontal part will also deflect a little bit because of rotation of the vertical part. Because of just, this is like L-shaped frame, and then if the vertical part is going to rotate, then the horizontal part is also going to rotate, and there will be a displacement downward. So now you can get the net displacement as theta into L plus PL cube divided by 3EI. What is theta for a simply supported beam with couple at the end? What is theta with simply supported beam with couple at the end? Simply supported beam with couple at the end, theta is nothing but ml by 3EI. Theta is nothing but ml by 3EI. So let's put it here. ml by 3EI into L plus PL cube divided by 3EI. Then put the value of m. M value is what? M value is P into L. If you put the value of m here, then you will get what? ml by 3EI. So then you'll get what? If you put P into L, then you'll get 2PL cube divided by 3EI. Okay, so you go for the answer. Now, let us try solving this 2016 problem. In this 2016 problem, let me describe this problem very quickly. They are saying that origin is here, okay? This is the origin. Because how do I know that this is the origin? Because you have y-axis like this and you have x-axis like this here. And they are saying that only for the second half segment, only for 0 to L. This is origin, so here you have x is equal to 0. Only for 0 to L, deflection is given something like this. Only for 0 to L, deflection is given something like this. Then what will be the slope? This is deflection given, okay? Don't get confused by W here. This is basically Y. Then they are asking what will be the slope at x is equal to 0. This is deflection, then what will be the slope at x is equal to 0. So let me reproduce this equation very quickly. They are giving you the deflection as minus m into x divided by EIL and L minus x and x plus c, and they're asking the slope. Obviously, they're giving you deflection and they're asking the slope. Obviously, the first idea that will come to your mind is to differentiate this. Now, if you differentiate this, then you're going to get, keep x and L minus x just like that. Differentiation of x plus c will become 1. Then keep x and x plus c just like that. Differentiation of L minus x will become minus 1. And then keep L minus x and x plus c just like that, and differentiation of x will become 1. Now they are asking the slope where? They are asking the slope at x is equal to 0. Put x is equal to 0. Put x is equal to 0. With x is equal to 0, this entire thing will become 0. With x is equal to 0, this entire thing will become 0. And with x is equal to 0, here you will have L and C remaining. So y dash at x is equal to 0 will become minus m divided by EIL, and only LC is remaining. L and L, they will get cancelled once again. Y dash at x is equal to 0 will become minus m into c divided by 12 EI. Because in the given equation 12 was also there, I missed it. In the given equation 12 was also there, I missed it. But here is a surprise. None of the given options will match. Because options are not given in terms of C. Options are given in terms of L. Okay? Options are given in terms of L. Options are not given in terms of C. So what do we do now? We must find out the value of C somehow. How do we find out the value of C? How do we find out the value of C? My dear friends, the best possible condition that you can use here to find out the value of C, listen, focus here and try understanding. You're applying M naught here, and keep this in mind that only for this part equation is given, okay? So whatever boundary condition you have to use, you can use only in this much beam. Now in this much beam, what is the boundary condition? One possible boundary condition is, in this much beam, one possible boundary condition is at x is equal to L, y is equal to 0. But unfortunately, at x is equal to L, y is anyway 0. At x is equal to L, y is anyway 0. This boundary condition is not going to help you. This boundary condition at x is equal to L, y is equal to 0. At x is equal to L, y is equal to 0. This boundary condition, my dear friend, is going to fail here. This boundary condition will not help you. Then what boundary condition you can use? At x is equal to 0, y is equal to 0 maybe? No. Why? And it is anyway 0. Once again, at x is equal to 0, y is anyway 0. So even this boundary condition will not help you. That means here, because left half of the beam will go down and right half of the beam will go up. So it is anyway 0, and this is again not helping you. I'm going to use one interesting boundary condition, and that interesting boundary condition here is what? Listen very carefully and try understanding. My dear friends, at x is equal to L, at x is equal to L, bending moment is 0, and we know y double dash is equal to m divided by EI. So if bending moment is 0, y double dash will be 0. My dear friends, if you use this boundary condition at x is equal to L, y double dash is equal to 0, then you will get the C value as 2L. I'm not elaborating it. I'm not, expanding it. I'm just telling you that you'll get the C value equal to 2L. If you put a 2L back here, then you'll get y dash value at x is equal to 0 as ml by 6EI. ml by 6EI, which is the third option, and which is the correct one. So gate problems asked from simply supported beams are pretty much only the tricky ones, but I'll solve some additional problems based on simply supported and overhanging beams in some other session that I'll make very soon. Thank you very much for staying tuned. Just make sure that you subscribe for the channel, and make sure, my dear friends, that whenever you are subscribing for Unacademy learning platform, use my code MTLive. Use my code MTLive to get 10% additional discount. Thank you very much for watching this session. Let's crack it.